Okay. All right, everybody. Welcome. Welcome on in. Continuing our discussion of things. Moving ahead. So you have stuff. We'll talk a little bit about rational expressions today, and then we're going to get on to radical expressions. There's a lot more to talk about with radical expressions, and a lot of it is less intuitive. So I think you'll be fine with rational expressions with what we talked about in class, and then going over the videos that are available to you, both from Delta Math and then seeing the worked out problems and that kind of stuff. So I'll do a couple of examples to finish out these chapters here, these sections here, and then we'll get into that new chapter. I do want to answer a couple of questions. So there was a question about the retake exam. That will be up later today, likely shortly after our class ends. I will get that up, and at least that's my plan. At the latest, actually I said Thursday or Friday. Tomorrow. I'll have it up tomorrow. I'll set it so it goes live tomorrow, and then you'll have about a week to take it, right? I was thinking today was Thursday for some reason. I'll set it so that the retake goes live tomorrow. You have about a week to take it. And then it'll run similar to how the test did. I want to be clear, though. I'm trying to say this every time so that everyone's clear. If you take that retake, that's your score. Okay, whatever score you get on the retake replaces the original no matter what. Okay, so just be sure if you want to take it. And I'm not trying to be scary or anything, but, you do kind of have to, a little bit, you got to earn the retake, and that's by doing the work, by doing the studying. If you've put in additional studying, then you should be fairly confident that you're going to do better, and then you can go for it. But if you got like an 85 and you're just you're waiting around and like, I don't know, we'll just see, maybe I'll do better, then, you're kind of taking a risk here. So it's the motivation. That whole thing is in place because, believe me, I didn't used to have that rule in place. I used to just say if you do better, the grade goes up, and it introduced a lot of problems into the system. So So that's the rule now, right? And it's fixed most of those problems. And the reality is I never see students come to me that spent an extra 3-4 days studying, took the retake, and did worse. It just doesn't happen, right? The only time that happens is that people's grades will be the same or sometimes lower if they didn't do any kind of studying. They didn't spend any time looking at the tests, and the grade is the same or lower. But if you're someone who thinks, I really should try to get that grade up, it's not where I want it to be, and you put in the time studying, you come to my office hours and you ask me for help, and we go over problems together, and you work on it in your own time, and you work your way through those problems you don't know how to do. You go to the tutoring center, whatever you need to do. If you put in that work, your grade will get higher, right? You're not going to do worse if you've put in that effort to studying. So I don't want to like scare anybody out of taking the retake. Just to sort of lay it out, the way to be successful is to do it correctly, right? Oops. Hold on one second. So, put in that effort and do the, study, and then take the retake if you have to. That should show up. I'll set it to show up tomorrow. And then you'll probably have up to and including, I don't know, next weekend or something. That gives you some time to sort of get ready for it. But remember, once you start it, then the clock is ticking, right? Just like the test that you took last time. Okay? And anyone who wants to come to my office hours with help, I'm happy to do that. But you have to bring me specifics. So, I do occasionally and even recently see where someone's like asking a very broad question. Like, can you look over all my stuff and then tell me what I need to do? No, but I can help you with specific questions. So if you come to me and you say, I don't understand how to do this type of problem from the test, yeah, let's look at it. But a specific one, like problem number 7 on this homework assignment, I don't get how to do. Can we look at it? Yeah, of course we can look at it, right? So just come with detailed problems. If you come to me and say, yeah, I don't understand factoring, okay, that's a whole chapter. What am I supposed to say, right? But if you come to me and say, this problem on the homework that's factored by grouping, I keep trying it and I keep getting it wrong. Here's what I get, and here's what the Delta Math keeps telling me it's wrong, but I don't understand why. and I've looked at this, when it shows me the results and I compare it and I'm close, but I'm not quite right, I'll look at that with you and we'll figure out what you're doing wrong. Okay? So that's available to you. Okay? I have office hours tomorrow. I have office hours next week. Okay, with that said, let's wrap up. Hopefully we can this one takes me a little longer to teach because writing out, especially, both of these last two sections, takes me forever to write the problems because there's a lot going on. I'll be honest with you, this is probably what most people consider kind of the worst part of the class. These two sections right here, adding and subtracting rational expressions. It's kind of what everyone likes to do the least, which is adding and subtracting fractions, except they're not even fractions. They're like complicated fractions, right? So I get this is not the most fun topic for most of you. I'll be honest, I don't love these topics either. Like, I don't find them much more interesting than you do. But we have to get through them, and you have to learn how to do them. So we'll get through it. But they do take me a little longer to type in because, in order for it to format, I'm basically using it's not technically a coding language. It's a scripting language, but it's a scripting language that interprets mathematics way faster than in like Microsoft. If any of you have ever tried to use Microsoft Equation Editor, it takes forever, right? So this software, as you see it updating for me as I'm typing it live. But for rational expressions, it does take me extra long to get everything written. So you just kind of have to, be a little patient with me today. Whoa, how did this happen? This doesn't look right. Get everything centered. Okay, so let's take a look at a problem and try to work through it. Actually, before we do that, I want to remind us how this works. So remember I told you before that if you ever get stuck dealing with rational expressions, just stop and remind yourself, rational expressions are just fractions with polynomials in them. And I know how to deal with polynomials, and I know how to deal with fractions, so I should be able to figure out how to deal with fractions of polynomials. And that's exactly what we're going to do here. So here's what I'm talking about. Let's say you go, I forget how to add rational expressions. Well, make yourself a problem with just fractions in it and ask yourself, how did you do that? So let's remind ourselves, how do I add two fractions together? Let's say I want to add together 1/3 plus 2/5. Okay, 1/3 plus 2/5. I want to figure out what this is equal to. Oh, darn it. They don't have the same denominator, right? And that's how it is most of the time in life. Your fractions are not going to have the same denominator most of the time. So we have to figure out what to do about that. Well, the answer is that we convert both of these fractions to have the same denominator. Okay. Now, there's different choices for this, but there's one really, really good choice for our new denominator. And that's what we call the least common multiple, right? And this is kind of, I think it was this class. Maybe it was my other class where we talked about it yesterday. The least common multiple is named after exactly what it is. Common, meaning shared. What do two things have in common? What do they share? So a common multiple, okay, that means if you start taking multiples of 3 and multiples of 5, which ones do they have in common? That means they share them. Okay, so we multiples of 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. Multiples of 5, 10, 15, 20, 25, 30, right? So they each have their own multiples. The common multiples are the ones that they share, the ones that are in common, right? So, for example, 15, 30, 45, 60, those are all common multiples. And you could convert these fractions to have a denominator of 60. But why? Why would you do that if you could get away with the least common multiple, which is 15? Wouldn't you rather deal with fractions where the denominator is 15 rather than 60? Yeah, you would. So then that's what we do is we look at these, and how do I know, like in this case it's the least common multiple. It's going to be a little bit more complicated when we're dealing with fractions because we don't really know what does least common multiple mean exactly with fractions, but really it means the same thing. It's just that the factors are harder. So I look at this and say, well, my denominator needs a 3 in it, and it needs a 5 in it. 3 times 5 is 15, And I think, are there any smaller numbers that those go into? No, no. Another way to do this with numbers is just start taking multiples of the bigger number and ask yourself, does 3 go into it? Does 3 go into 5? No. Does 3 go into 10? No. Does 3 go into 15? Yes. So then you've arrived at it, okay? But you need, basically, we need to include all the factors that occur in other denominators. We need to include those in our least common multiple, the new denominator. So here's how you want to look at these, right? There's kind of a way you can set this up, and if you learn the setup I'm about to show you, and you just write it on your page, the problem kind of finishes itself. This is one of those instances, again, I'll walk around the room, and I see a lot of people staring off into the distance, trying to like do it in their head. Don't. Just write it down, and you'll be 20 times faster than the people that are staring off in the corner trying to look at it because they don't want to write it down. So here's what you do. You take the fraction that you're dealing with. So we want to convert 1/3. So I'm going to take 1/3, and I'm going to multiply the top and bottom by some value. Right? What am I going to multiply it by? Well, we don't know yet. That's what we have to figure out. And then we're going to end up with some fractional number. So here's what you do is you go through and you say, okay, I've got the number. I'm going to multiply it by something, and I want to end up with a value of 15. So right here, we could just come up with a variable for now, like x and x, right? So I've got 1/3. I'm going to multiply the top and bottom by the same number, and I want to end up with a 15. Okay, so what does x have to be? What do I multiply 3 by to get 15? And the answer is 5. And I know the problem I'm doing right now, a lot of you are going like, why are we going over this? This is super easy. I'm going over it because it's the same exact procedure you're going to use for the problems today. It's no different except there's polynomials in them. But the actual procedure is identical. So what's missing? A 5. Oh, that means this x on top and bottom is a 5. I'm actually multiplying the top and bottom by 5. Okay, well then what does that mean on top? 1 times 5 is 5. Okay, so that means I put a 5 on top. Okay, so then what I'm claiming is that 1/3 converted to a denominator of 15 is 5/15. Is that right? Yeah. If I reduce this fraction, I get 1/3 again. Right. Now, here's a thing I see people do, because we're always telling our students to reduce fractions. I'll see people immediately take this fraction and reduce it. Well, if you do that, you just end up with 1/3. So I literally have seen students get in this infinite loop where they take 1/3, convert it to the right denominator, reduce it, convert it to the right denominator, reduce it. I've literally seen these infinite loops in my class. We will reduce our fraction at the end of the problem, but if we reduce this fraction now, you just end up in this infinite loop and you don't ever finish the problem. So for right now, just leave 5/15 as it is. Now what is our job? Our job now is to convert the other fraction, which is 2/5. 2/5. So 2/5. And we're going to multiply by some number. With a 15 on the bottom. Okay, so I've got 2/5. I'm going to multiply by some number over itself, and I end up with 15. So what am I missing here? 3. I'm missing a 3, right? So if I multiply by 3 on bottom, I'm going to multiply by 3 on top. That gives me 6/15. And I just want to look at it. Is 6/15 2/5? Yeah, those are equal to each other. Again, we're not going to reduce them yet, but look what we've done. We now have our two fractions, but they have the common denominator. If you reduce these, they won't have a common denominator anymore. So our original fraction, 1/3 plus 2/5, we've just decided is really equal to 5/15 plus 6/15. Oops, too big. We're running out of room. Let me do this on a different page here. Here we go. So here's a smaller version of it. I took 1/3 plus 2/5. We converted 1/3 to 5/15. We converted 2/5 to 6/15. Now we add these together. That gives me the fraction. So what do? We keep the denominator the same, so 15ths. And the numerator now becomes 21. No, it doesn't. It becomes 11. 11/15ths. 11/15ths cannot be reduced, so we're done. We just added those fractions together. This, like, when you're doing the rational expression addition, your work should look exactly like this, except instead of numbers, you're going to have polynomials in the top and bottom. But it is the identical procedure. So you literally already know how to do this. Now, it's helpful if you see me do one, but like, you know how to add fractions together. You're good. Okay, so don't psych yourself out, because I get it. These problems are boring and not terribly exciting, but that doesn't mean you can't do them. Okay, so let's take one from here. Actually, let's do a harder one. Here we go. Let's do this one. 5 over x minus 5 plus 1 over x minus 8. So see what we have? We have a fraction of polynomials here. And we're going to add these together. Right. So 5 over x minus 5. Was it minus? I think it was minus, wasn't it? Oh, plus 1 over x minus 8. Plus 1 over x minus 8. Making sure I copied it down correctly. Yes, I did. Okay. So I want to add these together. We're going to do the same exact steps we did up here. So I'm going to figure out what's the least common multiple for my denominator, right? You're going to hear me using literally the same language because it's the same problem. Okay, well, up here are factors. We needed a factor of 3 and a factor of 5, right? Well, down here we need a factor of x minus 5 and a factor of x minus 8. So what we do is we make a list of our factors. Our factors need to include an x minus 5 and an x minus 8 in them. Right, so there's my list. Almost not quite. Wait, how did this get big again? Weird, it's writing it so large again. Let's put it on a different line then, if it's going to be like that. And I'll put that back over here. Okay. So our factors, we need to have an x minus 5 and x minus 8. This is our least common multiple. This is our new denominator. We need an x minus 5 in it and an x minus 8. Okay, so with that said, what did we do here? We took the fraction and converted it to a new fraction with the denominator that we want. So that's what I'm going to do here. Let's take our fraction, which is 5 over x minus 5. I'm going to multiply it by some value. And then I'm going to get some new fraction, but that new fraction is going to have our least common denominator of x minus 5, x minus 8. Oops, looks like I'm off screen here. Okay, so we're going to multiply by something to get this. So what do I have to multiply x minus 5 by to get x minus 5 times x minus 8? I'm going to multiply by x minus 8. Well, if I do that on the bottom, then I need to do that on the top. So we're going to multiply by x minus 8 over x minus 8. See how when I multiply these together, I get this? So you can very easily, in fact, in some ways, it's easier with these rational expressions to see what you're missing part is, because you just look, well, here's an x minus 5, here's an x minus 5. What's missing? It's the x minus 8. I better multiply by that. Now you multiply across. Now, here's the thing where sometimes people don't quite understand how to do this step. You'll notice that I'm leaving the denominator factored, but you'll notice that I'm not going to leave the numerator factored. That's because when we do the addition or subtraction that is implied in the problem, in other words, this one right here, when we actually do this plus, our numerators have to be unfactored. If they're factored, we can't combine the terms together. If they've been multiplied out, we can multiply the terms together. So this will become, just distribute the 5 in, 5x minus 40. Okay, so see, it's the same thing we did before. I took my first fraction. I now converted it to have the right fraction, right? When you get a positive, not a negative, so you need to multiply by a positive. Where is that? Did I miss a sign? I'm not 100% sure where you're asking about the positive and negative. I think this looks right. So if you want to clarify, I'll be happy to address the question from chat. But I'm not 100% sure what you mean. Yeah. Okay. So now we just convert the other fractions. So now I'm going to get this. So we've got 1 over x minus 8. I'm going to multiply it by something. I'm going to get a new fraction, and that's going to equal a fraction that has the denominator x minus 5, x minus 8. Okay, let's see. You are multiplying x minus 5, x minus 8 and getting a negative. I haven't actually multiplied out x minus 5 times x minus 8. We're just leaving it in the factored form. We're multiplying it, and then these factors just stay next to each other. But we're not actually getting a negative. Up here, I multiplied 5 times x minus, the 5 times x minus 8. So 5 times x is 5x. 5 times negative 8 is negative 40. We have that piece. But we haven't actually multiplied out the x minus 5, x minus 8. In fact, we can leave it factored the whole time. Okay. And these are good. Keep asking questions. Anyone who has a question, throw them into chat, and I will try to address them. Okay. So here, what do we multiply x minus 8 by to get x minus 5, x minus 8? Well, I multiply by x minus 5. So we're going to multiply by x minus 5. Well, that means I have to multiply by x minus 5 on top as well, because we have to multiply by a form of 1. So once we figured out what we multiply by on the bottom, it's the same thing we're going to multiply by on the top. Okay, so then when I multiply 1 times x minus 5 going across, I just get x minus 5. Okay. All right, great. So now what do we have? We have converted our two fractions into having the common denominator. Now again, don't reduce this yet. Necessarily, both of these are reducible, but if we do that, we're just going to go in that infinite loop where we go back here, get a common denominator, reduce, common denominator. You just kind of, it's like a wheel spinning. You just sort of do the same thing. So we want to leave them in this form, but now we can combine them. So that means that our original problem is really, can be rewritten as, let's see, this fraction plus this fraction I'm going to run out of room here. Let's see. So you can kind of see there, our original problem, 5 over x minus 5 plus 1 over x minus 8, it looks a whole lot worse. Like, it looks like I made it worse, right? You're looking at it and you're going, that doesn't look any better than how we started. It looks like you're making it more complicated. Maybe, but what we did do was we got a common denominator. Once we have that common denominator, we can attack the top, right? We can figure out what to do with that. So let me take this part and rewrite it down here. So we have converted our, oh, darn it, I just grabbed the wrong one. Sorry, I'm trying to cut and paste to save time, and then it takes longer because I copy and paste the wrong thing. How did I possibly do that? Okay, here's what the problem looks like now. And I know it looks scary, but it's not bad. We're just going to go, okay, well, that means my new answer, well, the denominators don't change. So that should still be x minus 5 times x minus 8, right? Okay. Now, my numerators, I just follow whatever operation is indicated in the problem. So here it's plus. If it's a subtraction, then you just take the terms over here and subtract the terms over here. So 5x plus x is 6x. And negative 40 plus negative 5 is negative 45, which technically is factorable. Uh-oh, I have a... There we go. I had an error in the code here. So we get this 6x minus 45 over x minus 5x minus 8. Now, technically, this on the top is factorable because we could take a 3 out. But I think it's not going to care either way on delta math. Now, what you do want to do is see if this is factorable, because if you end up with a factor that's in the bottom as well, then you want to cancel those out. Just like we always say at the end of a problem, like when we did this one, I said, if your final answer can be simplified, then do it. We want to do the same thing here. If this is simplifiable, simplify it, but I don't believe it is in this case. So let's answer this question. This becomes 6x minus 45. And we'll see if I didn't mess this up. It's easy to make a mistake here. That was a long process we just did. Any little mistake along the way is going to mess it all up. So let's cross our fingers and hope I didn't screw anything up. There we go. I got it. Right? And then they give you the outline for it. And you can see they write it a little bit differently, but it's the same work, right? Remember when we multiplied this fraction by x minus 8 over x minus 8? And we multiplied this fraction by x minus 5 over x minus 5? They're just writing a little bit differently than I did. We sort of did it in separate pieces. They're writing it all in one line. Then you simplify. So remember, we got down to this part, 5x minus 40 plus x minus 5. Simplify, and oops. And then you're good to go. And it looks like I didn't even make any little mistakes. But don't beat yourself up if you do make a little mistake there. One little sign error is going to throw off the whole thing. And it's frustrating because, you know, what did that take me? 15 minutes to get through? If I screwed it up, I was going to be kind of frustrated. But that's just how these problems go. This is why this is kind of everyone's least favorite section for the whole class. So, and I get it. It's not, even those of us who are very experienced at math, we don't really enjoy doing these types of problems either. So I get it. Not the most exciting. Okay, so that's how you do those. Then we get to, where did it go? Uh-oh. We're missing something from here. Something's missing. How did I miss something? Let me see. Let me do this off screen, because poking around in Delta Math, sometimes all of a sudden everyone's scores show up, and I don't want that to happen. and then it logged me out of that one. Great. Let's see. Okay, give me 1 second because I've got to fix something here. This is math 3, right? Yeah, we're in math 3. So this is the one called addings. Oh, no, that's radical equations. Okay, I have to throw something else in here. So let's do this. Give me 1 second. Oh, I wonder if it's going to let me. Let me look for. Because the thing I have to add is the thing I'm trying to show you. So that's why it's important I put it in now. Here we go. Rational equations. So we're going to add. Yeah, stuff like this. There we go. Somehow that was missing. Okay, and then just let me see. For any of you who may have already completed that. Okay, almost nobody completed it. A few of you did. Looks like about 3 of you already did that assignment for adding and subtracting, solving rationals. Make sure you go back because I just added a couple more sections which I need to show you. Somehow they got left off. So go back to that homework assignment and complete the new problems, and then you can get back up to your 100%. Okay, so don't miss out on doing that. I know it's misleading, but somehow those sections didn't get added in there. I don't know how that happened. Okay, so with that done, let me go back in, and it's going to be math 3. So this one right here that was adding and subtracting, 3 of you had already completed that, but I just added the stuff that somehow got left out. So you have more work to do in there. Okay, so go back, hit that up, get those points right here, and get your grade back up to 100. Okay, let's look at one. So notice that inside of the problems where we are like we just did ones where we're adding rational expressions, right? Let me see if I can find one where I can show you what I'm talking about. Here we go. So here is an equation. We were just looking at rational expressions. We are now looking at rational equations. What is the difference? The equal sign. Okay, and that makes a big difference. A lot of times people get confused about what tools can we use with rational expressions, what rules can we use with rational equations. I talked about this with factoring, where people get confused between solving and factoring. It's the same thing here. Now, it would be very reasonable for you to look at this and go, this is going to be even worse than the section we just did because, look, it involves adding rationals. So not only are we going to be adding rationals, but then there's even more on top of that. Well, I have good news for you. It actually is easier, not harder. The reason it's easier is because of this equal sign. We are now dealing with an equation, and an equation allows us to bring our bigger toolbox, right? Rather than the little restricted toolbox for rational expressions, we can bring the full toolbox that applies to equations. So I definitely see this on tests where people treat this like it's an adding rational expression problem, which technically you can do it that way, but it's a lot of work, okay? A lot of unnecessary work, and generally students don't finish it when they do it that way. So what you want to recognize is we have a more powerful tool. You've been using this tool since it's like one of the first things you learned in beginning algebra, which is we have the ability to multiply both sides of an equation by the same thing, right? You were doing that way back when, the multiplication rule. Multiply both sides of the equation by 2 or something like that, right? So we can do that here. Well, why didn't we just do that with the last problems we did? Because there's no equal sign. How do you multiply both sides of the equal sign by the same thing if there is no equal sign? You can't. That's why that tool was not available to us. It is available to us here. Now, if I gave you this problem and said, you know, if you had a wish that was going to help you finish this problem, what would that wish be? And most likely your wish would be, well, if I had to finish this problem and I had to make a wish that was going to help me, I probably would wish that there was no fractions in the problem. Well, guess what? Your wish will come true. That's exactly what we're about to do. We're about to convert this equation to one that does not have fractions in it anymore. Awesome, right? So let's do that. So it's how are we going to do that? Again, we're going to do that by multiplying both sides of the equation by the same thing. So we had what? 1 over x plus 1 over x plus 4x over x minus 1 and then negative 8x over x minus 1. So that's going to be negative 8x over x minus 1. Did I get that right? Yeah, okay. I think I got that right. Oh, and you can't really see it on screen, can you? Okay, so what are we going to do here? Well, if we're going to get rid of those fractions like I promised, then what we're actually going to be doing is canceling out the denominators. How do you do that? You multiply by a factor that cancels with the factor in the bottom. So just like, how would we get rid of the fraction 1/2? Well, we'd multiply by 2, and then the 2 you're multiplying by would cancel, and the 2 in the denominator of 1/2, they cancel, and now you have the fraction 1. 1/2 times 2 is 1. It's exactly what we're going to do here. We're going to multiply the entire equation by the denominators that will cancel out those denominators. So just like last time, we list our factors. So the list of factors is what? Well, we need an x because of this denominator right here. And I need an x minus 1 because of these. Now, do I need 2 x minus 1s? Or do I just need 1? Well, if I multiply everything by x minus 1, then this one will cancel and this one will cancel. So we don't need x minus 2 in there twice. We just need it once. So x times x minus 1. Notice I'm not multiplying out that denominator, at least not yet, because we don't need to. Okay, so I'm going to multiply everything by this. So basically what we get is this again. See if I think this will fit on the screen. Let's see. Fit this again, except we're going to multiply by this. Okay, see how, you can't see how because it's not on screen. See how every part, I've got my 1 over x being multiplied by x times x minus 1. I've got my 4x over x minus 1 multiplied by x times x minus 1. I've got my last term multiplied by x times x minus 1. The rule that we're using says that you multiply the entire equation by the same thing. I sometimes see people pick and choose, and I go, well, why didn't you multiply this term by x times x minus 1? And they go, well, it wasn't a fraction, so I didn't need to get rid of the fraction. We don't get to do that. You don't get to pick and choose what gets multiplied by it. Everything has to get multiplied by it. That's like the common mistake. It's probably the number one mistake I see in this part of things. Now, why did I do that? This looks, again, you're going, Dr. Frederick, this looks worse. It looks like you're just making it worse rather than like improving things. What are you doing? Well, look what's about to happen. This is like the scary step, and then all of a sudden, everything's going to get better. Look at here, our x's cancel. Look at here. This x minus 1 cancels with this x minus 1. This x minus 1 cancels with this x minus 1. So it's all about to clean itself up, and then guess what? Your wish is granted. We won't have fractions in this problem anymore. So this is going to just become x minus 1, because that's what's left here. When the x's cancel, you have 1 times x minus 1. So we have x minus 1 to start with. Over here, when the x minus 1's cancel, you have 4x times x. So plus 4x squared. And then over here, when the x minus 1's cancel, we have a negative 8x times an x, giving us minus 8x squared. So what do we have? Well, as promised, we now have an equation with no fractions in it. Awesome. Okay. Well, we do have a quadratic. That's not great, but hey, guess what? We learned how to deal with those last chapter. So we know how to finish this equation now. Okay, so let's continue. If I add 8x squared to both sides, then I'm going to have 12x squared plus x minus 1. If I have a typo in there, let me know. Don't want to spend all this time and then do it wrong. So if I've screwed it up, feel free to let me know. And then, of course, we have equals 0 because it's an equation, right? Equals 0. So what we're going to do, remember back to just last chapter, we're going to factor the left side and then use that zero product principle. Hold on one second. Hello? Sorry, I'm expecting kind of an important call, and I had to answer that, but it ended up being one of the extended warranty scams. So sorry about that. Okay, so we've got 4x squared, and then I've got a 3, oh, nope, just 4x, and then a 3x, and then we're going to have what? Plus, I think it's going to be plus 1 and minus 1. So here I'm just factoring, so hopefully you remember this from last time. So let's see, or from last chapter. So let's see, 12x squared plus 4x minus 3x minus 1. Yep, okay, that looks right. So when we go through and solve these, we now set each of these factors equal to 0. So 4x minus 1 equals 0, right? Remember doing this? So 4x minus 1 equals 0, or 3x plus 1 equals 0, which means that this would be what? X equals 1/4. Or, just going for the sake of time, so you can fill in these couple pieces right here since we already learned it. That would be x equals negative 1/3. If I'm doing this right, it's possible I'm messing it up. So 1/4 or negative 1/3. Now here's where it gets a little bit tricky. We're used to, when we solve an equation, what we get is a solution. Assuming we didn't make any mistakes, we know it's going to be a solution, right? We don't get to play that game anymore. You have to check your work. And a lot of people, they get in the practice of thinking that, well, checking your work is making sure that you didn't make mistakes. No. Even if you, even if we did everything right, we could get an answer down here that is wrong, right? And it's because we paid a price for making our problem easier. We decided to make our problem easier by eliminating the fractions, but in doing so, we paid a price. And that price is that you can introduce what are called extraneous solutions. That is, you can introduce answers that aren't actually solutions. So you definitely want to check the values before you plug them into Delta Math, because otherwise you'll get it wrong and then you lose that score, right? So don't think of checking your work as like finding your mistakes. It's not. This process requires us to double check that the things at the end are actually solutions. All right, there's a question. So with the x times x minus 1, you basically cancel it out. Yeah, so the parts canceled out. Whatever was in the denominator would cancel with that part up here. So the x minus 1 here cancels with this x minus 1. This x cancels with this x. Okay. So I think these are both going to work. So let's see if I got it right or if I screwed up. So x, there's two answers here. 1/4 and -1/3. Are those my answers? Let's see if I got it right. Whew. Okay, I got it. And you can see they did the same thing I did, right? You can see right here, they're multiplying by x times x minus 1 times each term. It kind of helps they have it in green so you can see it a little bit better. And then once you do your canceling, you see what's left. I see how this is what's left here. This is what's left here. This is what's left here. And then you just solve that quadratic like you did last chapter. And then, yeah, you check for extraneous roots. That's what I was talking about, the extraneous solutions, extraneous roots. I guess you could call it extraneous roots. That actually seems like a little bit of a stretch, but either way, it's good enough. Extraneous solutions, extraneous roots, you plug it in, it works, you get your final answer. So that's how those go. So I did not get into the next chapter, but we were able to wrap up the chapter that we're in. So remember, the retake will come online tomorrow. You'll have about, I don't know, 8 to 10 days, depending on when I make it due, to work on it. So make sure you're studying up. I have office hours tomorrow. I have office hours next week. Please come get help with me, right? I know some people are intimidated to ask for help, and you know, talking to other humans sometimes is you know, stressful for people. Come to office hours and get help, right? It's worth getting an extra 10 or 15% on your test if you can learn how to do some of those problems correctly. Those of you who are happy with your score, don't need to take the retake, don't need to worry about it. Those of you who do, study up and get ready. Okay, so I'll close down the stream. Anyone who wants to hop into Zoom, feel free to do so, and I will see